Dear ladies and gentlemen, a warm welcome to my YouTube channel. Let us learn something new with SUBBU.
Today, in this video, we will try to learn something new about the tropical cyclones, also known as hurricanes, typhoons, and Willy-willy. These tropical cyclones are the most disastrous natural hazards. Let us begin now. I am hopeful that you will enjoy the contents of this video. Don't forget to press the like button and subscribe to my channel for receiving regular updates.
Tropical cyclone reminds of very disturbing scenes. Very high winds, intense rainfall, uprooting of trees, human casualties. And these cyclones are natural. Isn't it surprising that these hazards are natural and not man-made?
To this, I may probably like to pose a question to myself. Why is this balanced nature behaving so much imbalanced? Well, I don't have an answer to this question right now, but we can explore this point. In the last slide, I mentioned about a natural imbalance. Now, let us try to understand what I meant with this natural imbalance.
First and foremost, we know since our schooling that the Earth has 7 continents and 5 oceans. But whether the fraction of land and oceans is equal? No, it is not. About 71% of the Earth's surface has oceans, while only 29% has land. Isn't it an imbalance? Yes, it is. Secondly, the specific heat of oceans and land is not equivalent. It means that even though they receive equal amount of solar radiation, the land surface warms more rapidly than the ocean. Isn't it another imbalance? Last but not the least, the sun sends equal amount of radiation to Earth, but it is not distributed equally. The equatorial region receives a surplus of solar radiation, while the polar regions have a considerable deficit of radiation. In addition to all these, the distribution of heat energy changes its pattern within 6 months from the winter and summer solstice. Now it may be clear that, due to this natural imbalance, we can have cold air somewhere and warm air somewhere else. That too, simultaneously. Let us move one step further. How will they behave when they coexist? Cold air means more molecules. More molecules mean more weight. More weight means more pressure. And the behavior of warm air is just the opposite. Warm air means fewer molecules. Fewer molecules mean less weight. Less weight means less pressure.
In short, we can conclude that the warm air can be associated with low pressure, whereas the cold air can be linked with a high pressure region. So warm region means low pressure region, and cold region means high pressure region.
When a high pressure and a low pressure regimes coexist, the winds tend to blow from the high pressure regions to the low pressure regions. And this is how a natural wind circulation sets in. However, the direction of wind circulation has also a considerable dependence on the Coriolis force.
The Coriolis force is a fictitious force, which acts on objects that are in motion within a frame of reference that rotates with respect to an inertial frame. Since the Earth is spinning around its axis, this Coriolis force plays an important role in the formation of a wind circulation system.
Let us examine how a low-pressure system behaves in the northern and southern hemispheres. A low-pressure system pulses the winds from all around. Thus, a low-pressure system can be also seen as a converging system.
The Coriolis force pushes a moving body towards its right side on the northern hemisphere. On the other hand, this Coriolis force changes the direction of a moving body towards its left in the southern hemisphere.
Resultingly, a low-pressure wind system becomes a counterclockwise circulation in the northern hemisphere and a clockwise circulation in the southern hemisphere. This is clear from this picture here.
Now, we have reached quite closer to defining a cyclone. A cyclone is defined as a larger scale air mass that rotates around a strong center of low atmospheric pressure. In other words, we can define a cyclone as a low-pressure atmospheric system over a warm oceanic region. Literally speaking, the word cyclone is adapted from a Greek word cyclos, which means coiling of snakes. The central region of a cyclone is called the eye of the cyclone.
Now we know that a low-pressure system is called a cyclone. But, how much low must the low pressure be? As per the standard definition, as soon as the central pressure drops by more than 6.1 hectopascals, the low-pressure system is called a cyclone. And broadly speaking, the atmospheric pressure over the eye of a cyclone can be as low as 0.5% to 15% of the surrounding air. If we do a little bit of mathematics, it works out to be as low as 5 hectopascals to as large as 152 hectopascals. The cyclones are vaguely classified based on the region of their occurrences. In this way, we can have tropical cyclones and temperate, or extratropical, cyclones, as shown here. The polar regions extending from 60 degrees to the north and south poles are reasonably cool and do not offer favorable conditions for the formation of cyclones.
As per the Indian Meteorological Department, IMD, the tropical cyclones are classified into different categories based on their intensities. The intensity of a cyclone is measured by the pressure drop and the maximum sustained surface winds. Based on these two parameters, a cyclone is classified into well-marked low, depression, deep depression, cyclonic storm, severe cyclonic storm, very severe cyclonic storm, extremely severe cyclonic storm, and finally, super cyclonic storm.
Worldwide, these cyclones are also known as the hurricanes, typhoons, Willy-willy. Anyways, it doesn't make any difference. All are one and the same. In an analogy, we can recollect the famous phrase by William Shakespeare. What's in a name? That which we call a rose, by any other name would smell as sweet.
Whether I call it as a tropical cyclone or as a hurricane, it will still remain the same devastating natural hazard, isn't it? Let us now try to memorize few important points about the tropical cyclones. Qualitatively, a tropical cyclone will have a system of thunderstorms, a strong wind circulation around a low atmospheric pressure, a wind system rotating inwards, counterclockwise in the northern hemisphere. The eye of a cyclone can have an average diameter of about 20 to 30 kilometers. Their average diameter of total cyclone is about 150 to 250 kilometers. And these cyclones typically move with an average speed of about 300 to 500 kilometers/day.
Let us examine the global distribution of tropical cyclones. Very first and foremost important fact, approximately 96 cyclones are reported annually. And if we take our neighboring oceans, i.e., the northern Indian Ocean comprising the Bay of Bengal and the Arabian Sea, they account for approximately 4% to 7% of annual cyclones worldwide. This plot shows the number of cyclones formed over different grid boxes during the last 120 years. It is very clear that the Bay of Bengal has substantially more number of tropical cyclones than that over there. Now, we will examine the seasonal dependence of tropical cyclones over the northern Indian Ocean. We know that the Indian climatic conditions are divided into 4 prominent seasons. Winter, January to February. Pre-monsoon, March to May. Southwest monsoon, June to September. Post-monsoon, October to December. Based on the climatology on the occurrence of tropical cyclones over the Bay of Bengal and the Arabian Sea, it is seen that the pre-monsoon and the post-monsoon seasons offer favorable conditions for the cyclogenesis.
Here, we can have two prominent questions. First, why the Bay of Bengal has more tropical cyclones than the Arabian Sea. Second, why the post-monsoon and pre-monsoon seasons offer favorable conditions for the cyclogenesis. Ladies and gentlemen, these questions need to be answered in detail, and I will make a separate video on this topic shortly. Please remain subscribed to my channel for receiving regular updates. For the time being, let us go ahead.
There are few meteorological and oceanographic conditions which are considered conducive for a cyclogenesis. They are described here. The pre-existence of a disturbance is considered favorable for cyclogenesis. Warmer sea surface temperatures, more than 26.5 degrees Celsius is also a well-accepted threshold for cyclogenesis. For cyclogenesis to take place, a considerable amount of Coriolis force is also mandatory. And we know that the Coriolis force is a function of latitudes, and its value is minimum over equator. Hence, there are generally no tropical cyclones within ±5 degrees of equator. In addition, large values of tropospheric relative humidity and degree of convective instability and low magnitudes of vertical wind shear are also important factors for cyclogenesis. Since these tropical cyclones are extremely devastating in nature, an accurate and timely prediction of these cyclones is a must. 6 regional specialized meteorological centers provide formal prediction of cyclones. For the Northern Indian Ocean region, we have one RSMC at New Delhi, functioning round the clock to meet the requirements. Now, let us also discuss one other important and curious question: who gives the names to these tropical cyclones? Well, the names of tropical cyclones are given to make things easy in many aspects. For the Northern Indian Ocean region, the name of tropical cyclones is given by Economic and Social Commission for Asia and the Pacific, SCAP, of the World Meteorological Organization. Earlier, 8 countries, Bangladesh, India, Maldives, Myanmar, Oman, Pakistan, Sri Lanka, and Thailand were the part of SCAP. Very recently, 5 more countries have joined the SCAP, and now the names of tropical cyclones is proposed by all the member countries, and the names are taken sequentially. Here, we can see the names already given for the future tropical cyclones over the Northern Indian Ocean.
So that's it for today, guys. I know there are many aspects of the tropical cyclones, which I could not cover for the lack of time, but I am hopeful that this video might have helped you to understand the cyclones better now. If you have any specific question about the tropical cyclone, you may please mention them in the comment box. I will surely revert back to you in due passage of time. Thanks again to all of you for your patience and attentive participation in my video. Don't forget to like this video and subscribe to my channel.
Time to say goodbye, ladies and gentlemen. Please like and share this video. And don't forget to subscribe to our channel for receiving regular updates and more educational videos.